Hello, so today we are going to continue on problems from exercism.org, the Kotlin track. The problem we are looking at today is triangle. So the problem says that we want to just determine if a triangle is equilateral, isosceles, or scalene. And so basically equilateral is three sides the same length. Isosceles is two sides of the same length. And the last one is all sides have different length, right? And then one more requirement is that for a triangle to be a triangle at all, you need all sides to have length bigger than 0, right? And you need also the sum of the length of any two sides to be greater than or equal to the length of a third side, right? So yeah, basically triangle inequality rule. Okay, so let's see how we can do that. We have the test cases. I already have everything here. So the first iteration, I'm going to go through multiple iterations so we can see how we can improve the code, right? And so the first one, so to make it easier for ourselves, we just make them all numbers because we can be passed int, float, doubles. Now the first thing we want to do is in the constructor, we want to reject any non-valid input. So for example, here, if we, in this test case, we get a triangle that violates triangle inequality, and so we want to reject it and throw an illegal argument exception, right? And so to do that, we just define this invalid function. If the sides are not valid, we just throw an exception. Now, to check if the sides are not valid, we have two conditions, whether it's a triangle at all, right? And whether it has triangle inequality. So triangle at all means all sides needs to be bigger than 0. You can't have a triangle with the side equal to 0. And so we use this all uniterable, where you passed a predicate that returns a boolean. And basically it returns true if all the elements in the iterable return true. If any element in the iterable doesn't return true, it returns false. And so here we make sure that all the elements in the sides are bigger than 0, okay? And to be able to check bigger than 0, we have to convert to some number, and so we just convert to a double, right? Even if it's 0.0 something, this check would work. And for the sides itself, it's just the list of all three sides. For triangle inequality, because we need to check that a side is smaller than the two-sum side, right? We can just, if we check that the biggest value, right, is smaller than the sum of two other sides, then that sort of guarantees that the other ones should work as well. And so we just get the sides, we sort them, and we check that the last one, which is the biggest one, is smaller than the sum of the other two. And for equilateral, of course, we do the check each time. This is not necessary, so we can remove it, right? Because we already did the check at initialization here. And this is just the definition. So equilateral, all sides equal, isosceles, sides are, at least two of them are equal. And the last one, all of them need to be different, right? That's what this check does. Okay, so how can we improve this a little bit? Let's see the second iteration. So with this one, what we can do actually is simplify the logic here. So before we used to do all of this stuff, right? All of these equality checks. So what we can do instead is get the list of sizes as a set. So that will give us the unique ones and get the size, right? If the count of the unique ones is 1, that means they are all equal. So that means we have this condition. If the size is 2, that means only 2 are equal, right? And that's exactly what we want for isosceles, right? And for the last one, if they are all different, the unique count would be equal to 3, and that's what we have here, right? So that's a slight improvement there. Can we do more? So let's take a look at this last one. And the first thing we can do, let's compare it against the second one. The first thing we can do is we can instead of throwing ourselves illegal argument exception, we can use this require function, which is basically does that. It throws an illegal argument exception if the value given to it, which is the is valid value, if it's false. So if the input is not valid, it will throw an exception. So you can see actually that it does that here. So you can see if the value is false, it does throw an exception, right? You can pass it a function with the message if you want. So let's say you want to pass it a function, you can just pass it like this that says the message. So for example, we can say something like this: triangle is not valid, and that should work fine. Okay, so that's an improvement over writing the entire thing ourselves. You have also similar ones that can be helpful here, like check. So if we just take a look here, check Boolean value. Yeah, what it does is throws a illegal state exception. So it sort of checks a class state. Okay, and so we keep the same thing, except for the sides, we sort them from the beginning, right? Instead of doing it for has triangle inequality. That way for checking if triangle is valid, we can just check if the smallest one is bigger than 0, because if the smallest one is bigger than 0, since the other ones are bigger than it, then they have to be all bigger than 0, right? So this is a clever way of simplifying the check. And then for the sides, we can just make sure that all of them, instead of relying on just one check, we can check that all of them, right? If we remove one, if we remove that element, right, which is the it pointer, if we remove it and take the sum, which basically just leaves the other two elements, then that would be bigger than the element itself, right? So for each element, we removed from the side, we sum the other two and make sure that that sum is bigger than the element. And that will actually verify the triangle inequality for all sides of the triangle, right? And this is a clever way to check. Yeah, so this is, I think, a lot simpler solution than the original two, or at least better. Yeah. So yeah, that's it for today's problem. Please like and subscribe, and see you on the next one. Bye.